Welcome back, guys. Today we're going to be taking a look at topic 5.2, which involves solving quadratic equations using the quadratic formula. So just as a quick refresher, in our last class we looked at solving quadratic equations by graphing and by factoring. And then today we're going to be taking a look at the quadratic formula, and in our next lesson we're going to be looking at solving by completing the square. All right, so what is the quadratic formula? Well, this is that big formula right here that says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is not a formula that you need to memorize right now. It is on your formula sheet. However, likely after you've used it a few times, it will get easier, and it's something you will probably have memorized. Now, again, just as a reminder, the roots of the quadratic equation are basically our solutions to x. When we're graphing, those are also our x-intercepts. So roots, zeros, and x-intercepts are all essentially the same thing. Now the question is, when do we use the quadratic formula? Well, we can use the quadratic formula anytime that we would be factoring a trinomial, but usually the primary time to use it would be when we can't factor a trinomial. So again, if you're struggling with factoring, you can absolutely use the quadratic formula to help you out to find your roots. But especially when we can't factor a trinomial, then we definitely have to use the quadratic formula. All right, so let's take a look at a quick example here. Now, before we start using the formula, just a reminder that when we're dealing with quadratics, our standard form is ax squared plus bx plus c equals 0. So 3 would be our a value, positive 5 would be our b value, and negative 11 would be our c value. So when we're looking at our coefficients, the sign in front is very important. All right, so we have our parameters determined. Then we're going to substitute into our formula. So again, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So our b value is 5, so we've got negative 5. If that b value had been negative, we would have had a negative, which would become a positive. So here we have negative 5 plus or minus the square root of b squared, so 5 squared. Brackets, again, are important because if this had been negative and we didn't put the brackets, we would end up with the wrong answer. So 5 squared minus 4 times 3 times negative 11. Now, obviously, with a positive 5, we don't really need to put the brackets there, but I get in the habit of doing it all the time so that when there is a negative, it's not an issue to have to remember when I use the brackets and when I don't. So again, negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 11, all divided by 2 times a, which is 2 times 3. Now we can simplify underneath the radical. So we have 25 plus 132, which simplifies to 157. Now, when we want to put this in our calculator, we have to put it in 2 steps. The only reason to put it into our calculator is so that we can double check our answers by checking our approximations. Unless you're told otherwise, you should keep your answers exact. So checking this in our calculator, we're going to start off by putting the numerator in. So we've got negative 5 plus the square root of 157. And then I'll hit enter and divide by 6. Now you can absolutely put this in your calculator all in one step, but then you have to remember to put in brackets. So usually I'll put in the numerator and then I'll divide by the denominator. All right, so we have an approximation there of 1.25. Now we can retype this again, or you can pull up your old entries. With the newer calculators, you can just arrow up and grab your answer. But we just have to go in and change that plus sign to a negative. So negative 5 minus root 157, and then divide by 6, gives us negative 2.92. So if we wanted to verify this in our calculator to make sure that we've done it correctly, we can go into our y equals, we can graph our original function of 3x squared plus 5x minus 11. We'll go zoom standard. And again, I can't see the entire graph on there, but really what I'm looking at is the x-intercepts. Now remember, we have 2 different ways that we can check for our x-intercepts. We can plot a line at y equals 0 and then intersect our quadratic with the y equals 0, or we can use second calc 0, and then we do our left bound, right bound. So left bound is on top, right bound is below. So our first x-intercept is negative 2.2 or 2.92. So that matches what we had. And we'll find the other 0. Left bound is below, and right bound is above. And we have 1.25. So again, we keep our answers exact unless we're asked to approximate. But the benefit of approximating is it helps us to sketch our graph so we have an idea where to put those points. And then we can also verify with our calculator. So again, by checking with our calculator, we know that these answers are correct. Our final answer, however, would be negative 5 plus root 157 over 6 and negative 5 minus root 157 over 6. Now, taking a look at our first example here, we have 3x squared plus 2x equals 4. Well, the first thing we're going to do is rewrite this with all of our terms on the left-hand side. So we have 3x squared plus 2x minus 4 equals 0. Remember, anytime we're dealing with quadratic equations, we need to have an equal sign. So we label our parameters here. We have a is 3, b is 2, and c is negative 4. And then we can usually, when we're doing the question, write out our formula, but just to save space, I'm going to go straight into the substitution. So that gives us x equals negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4, times a is 3, times c is negative 4. Again, those signs are super important. And then we're dividing by 2 times a, which is 2 times 3. Moving down, we're just going to continue simplifying as we go. So we have negative 2 plus or minus the square root of 4, and then negative 4 times 3 times negative 4 becomes 16 times 3, which is 48. So 4 plus 48, all divided by 6. Continuing to simplify, we're going to have x equals negative 2 plus or minus the square root of 52, all divided by 6. Now 52 can be broken down because we have root 52 is the same as root 4 times root 13, and then root 4 breaks down to 2. So simplifying this, we would have x equals negative 2 plus or minus 2 root 13, all divided by 6. Now each of these terms can be divided by 2, so we'd have negative 1, negative plus or minus 1, and then 6 is 3. So if all of our terms can be divided by the same coefficient, then we can simplify. So another way to look at that is that we're factoring out a 2. So we pull out a 2, and that leaves us with negative 1 plus or minus root 13, all divided by 6. And then that would leave us with a 1 and a 3 on the bottom. So again, we would have negative 1 plus or minus root 13 all over 3. So writing that out, we have negative 1 plus or minus root 13, all divided by 3. Now, subbing into our calculator again, if we wanted to get some approximations to check our answers, we'd have that x is approximately 0.87 and x is approximately negative 1.54. But again, our final answer should be left exact, so negative 1 plus root 13 over 3 and negative 1 minus root 13 over 3. So moving on to our next example, we have x squared minus 6x plus 7. When we don't see a number in front of our variable, that means our coefficient is 1. So labeling our variables, we have a is 1, b is negative 6, and c is 7. So subbing into our formula, we're going to have x equals negative b, so a negative negative 6, plus or minus the square root of b squared, so negative 6 squared. This is where those brackets are super important. Minus 4 times a is 1 times c is positive 7, all divided by 2a, so 2 times 1. Now we just simplify as we go, so a negative negative 6 is positive 6, plus or minus the square root of 36 minus 28, all divided by 2. Now some of you may simplify everything under the radical all at once. That's totally fine. For the purposes of the notes, I'm writing it out step by step. So we're going to have 6 plus or minus the square root of 8 divided by 2. And then root 8 can be broken down to root 4 and root 2, and root 4 breaks down to 2. So continuing to simplify, we're going to have x equals 6 plus or minus 2 root 2, all divided by 2. Now again, after we've simplified, we can see that all of our terms are divisible by 2. So we're going to divide each by 2. That leaves me with 3 and 1 and 1. And so my final answer is 3 plus or minus root 2, all divided by 1, which is just 3 plus or minus root 2. And again, we can check that on our calculator. We would have 3 plus root 2 and 3 minus root 2. So our approximations, if we were checking this with our calculator, would be 4.41 and 1.39. Now moving on to one more example here, we have 1/4 x squared minus x minus 3. Again, we would have a negative 1 right there. So our a value is 1/4, our b is negative 1, and our c is negative 3. So subbing into our formula, we're going to have x equals negative b, so a negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times 1/4 times negative 3. Again, be careful of those negatives and make sure you're using your brackets. So we're dividing by 2a, so we're dividing by 2 times 1/4. And then simplifying, we're going to have x equals positive 1 plus or minus the square root of 1 plus 3. So negative 4 times a positive 1/4 becomes negative 1. Negative 1 times negative 3 is positive 3. All divided by 2 times 1/4, which is 1/2. Now you can write that as 1/2, or you can write it as 0.5. If it's a nice decimal, absolutely you could write it as a decimal. If that was a repeating decimal, we would have to keep it exact. So now we're going to have 1 plus or minus the square root of 4, all divided by 0.5. Now simplifying, we have x equals 1 plus or minus 2, all divided by 0.5. So we can break this down. 1 divided by 0.5 is 2, plus or minus 2 divided by 0.5 is 4. So we have 2 plus or minus 4. This one will give us exact answers. So 2 plus 4 is 6, and 2 minus 4 is negative 2. So we'd have two answers, positive 6 and negative 2. And again, we can always double check these on our calculator by graphing. So we have 1/4 x squared minus x minus 3. And then we zoom standard. And we double check. So second calc 0, left bound, right bound. So we have negative 2. And then we'll double check here. If I trace at 6, we see that 6 comma 0 is also our other x-intercept. So if you already know your answers, you can just trace at the x value and verify that your y equals 0. Okay, so we're going to move on to 2 practice questions here. What I'd like you to do is pause the video, do these questions on your own, and then come back and check your answers. Now remember, you can also verify by checking with your graphing calculator. All right, so pause the video and then come on back. Okay, now let's take a look at your answers. So for the first one here, we subbed in negative 1 plus or minus 1 squared minus 4 times a is 2 times c is negative 6, and then divided by 2 times a, which is 2 times 2. Simplifying down, we end up with negative 1 plus or minus the square root of 49 divided by 4. Root 49 breaks down to 7. So we have negative 1 plus 7 divided by 4 gives us 3/2. And negative 1 minus 7 divided by 4 gives us negative 2. So you can write these as separate answers, x equals 3/2 and x equals negative 2, or we can write it with a comma in between. So x equals negative 2, comma 3/2. So again, if these break down to nice numbers, so nice rational numbers, then we can write out those answers. If not, then we leave it in that plus minus format with the roots. So for part B here, we have negative 3 plus or minus the square root of 3 squared minus 4 times 5 and negative 3. And that's all divided by 2a, or 2 times 5. Now this one breaks down to negative 3 plus or minus root 69. We cannot break down the root 69. So we would just leave our answer as -3 plus or minus root 69 over 10. But again, if we want to verify that on our calculator, we can check with the approximations. So we would have -3 plus root 69 divided by 10. And then we have -3 minus root 69 divided by 10. Now, if you wanted to verify this all at once, you could absolutely do that. So we could start right off the top here with everything not broken down. So we would have -3 plus the square root of 3 squared. Now, if I know that this is going to become positive, I might not put those brackets. So even if that had said like a -3 squared, I know that -3 squared becomes 3 squared. So to simplify it in my calculator, I might just leave it without the negative. So 3 squared minus 4 times 5 times -3. Again, this negative is super important. Close your brackets, and then we divide by 2 times 5, which is 10. And then again, we can re-enter that, or just pull up your old entry and change the sign to be negative. So I usually don't retype it a second time around, I just change my sign. And then we divide by 10, and we have our answer. Now let's take a look at an application problem here. So in this problem, we're told that the height of the Peace Tower in Ottawa is 90 meters. And if an object is thrown downward at 5 meters per second from this height, the time, t seconds, so time is in seconds, that the object takes to reach the ground can be found by solving the following quadratic. So we have negative 4.9 t squared minus 5t plus 90. Notice that where the object is starting from is 90, and that's also our constant, which is also our y-intercept. Now we're asked to determine the time to the nearest tenth of a second for the object to hit the ground. In other words, when is the height going to be 0? So if this had been a factorable quadratic, then we would be able to just break it down into its factors and set it equal to 0. That's not the case. So we've got negative 4.9 t squared minus 5t plus 90. So we're going to have to use our quadratic. So our a value here is negative 4.9. Our b is negative 5. And our c is 90. Now, subbing into our formula, the formula does say x equals, but in this case, we're going to write t equals because our variable is t. So we've got t equals negative b, so a negative 5 is a positive 5, plus or minus the square root of negative 5 squared minus 4 times negative 4.9 times 90, all divided by 2 times a, or 2 times negative 4.9. Now simplifying this down, we're going to have 5 plus or minus. Now we've got negative 20 or negative 5 squared, so 25 minus 4 times negative 4.9 times 90. Well, that'll give us 1,789, and all divided by negative 9.8. Now this doesn't end up breaking down. The root 1789 we won't break down, but whether it did or not, we're being asked for the nearest tenth. So my next step would be to put this into my calculator. So substituting, we'd have 5 plus second root 1789, and then divided by negative 9.8. That gives us negative 4.8. And then pulling up my old entry here, I would have negative or 5 minus root 1789 divided by negative 9.8. So that gives us our second answer. We've got negative 4.8 and positive 3.8. So writing those down, we have t is approximately negative 4.8 seconds, and t is approximately 3.8 seconds. Now, if this was just solving of a quadratic, we would write both of those answers down, but we have to consider the context of the question. We're talking about time. We can't have negative time. So this one's eliminated, and our answer is 3.8 seconds. So we're asked to determine to the nearest tenth of a second how long it takes the object to hit the ground. So it takes 3.8 seconds for that object to hit the ground. So again, if we wanted to verify this with our calculator, we'd put our equation into our y equals. So that's negative 4.9 x squared minus 5x plus 90. Now in this case, we have to play with our window settings a little bit. So we think about the context of the question. We're not going to have negative time. And since we know that our answer is 3.8, going up to 10 is fine. And then thinking about our height, we know that it's starting at 90 and being launched up. So I might go up to 150, go up by 10s, and then we can graph. Now we want to see where it intersects with the x-axis. So I could draw a line at y equals 0, or again, I could find my zeros. I go second, calc, intersect, and we check where those points intersect. And again, 3.8. So we can use our calculator to verify our answers. So one more thing I want to take a look at here is where this formula comes from, or how we get the quadratic formula. Some of you may have been wondering throughout the lesson, well, where does this formula come from? Like, how do we get a formula like this? And the answer is by completing the square. So if we take our original quadratic in standard form and we complete the square and do a little bit of algebra, we can actually get our quadratic formula. So we start off with ax squared plus bx plus c equals 0. And our first step is to move our constant to the right-hand side. So we're subtracting c from both sides. And that leaves us with ax squared plus bx equals negative c. Our next step is to factor out our leading coefficients. So we factor out an a, and that gives us x squared plus b over ax. So when we're dividing by a, we're going to be left with b over a. Now we're going to move that coefficient, so we're going to divide both sides by a, and that's how I'm getting negative c over a. And then I'm going to continue by completing the square. So if you remember, our next step is half squared. So we're going to have b over a divided by 2, which is the same as b over a times 1/2. And that gives me b over 2a. So that's our half. And then when we square it, we would have b squared all over 4a. So notice here we've got our plus minus b squared over 4a squared. Now, continuing on by completing the square, we're going to pull out that last term. And since there's nothing to multiply by, there's no coefficient here to multiply by, we just pull that out. So we've got x squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared. And again, the right-hand side of the equation hasn't changed. Now, we're going to move this over. Okay, so we're trying to isolate those brackets. And after that, we're going to factor. So remember, this is a perfect square. So when we're completing the square, we should always have a perfect square. So our factor ends up being x plus b over 2a all squared. And at the same time here, I've just been combining my fractions. So I multiply this by 4 and by 4a and by 4a, and that will give me my common denominator. This is something that we'll get into in another unit, so it's okay if you're not understanding how I'm combining those fractions yet. And then we square root to get the left-hand side isolated, or so to get that inside piece isolated. Now, when we square root, we end up with plus or minus the square root of b squared minus 4ac all over 4a squared. So this you're probably starting to see come together a little nicer. And then we're going to bring over the b over 2a, because ultimately our goal is to isolate x. So now we have negative b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. Now we can apply that radical to the numerator and the denominator, simplify it down, and notice that we have common denominators. So now we can break it down, or we can simplify, and we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, that's the derivation. That's how we're getting to our answer. Certainly, this is not something I would expect you guys to be able to do on your own. But for those of you, especially those of you that are moving on to higher level math, definitely something valuable to look at, because you will see derivations as you move forward into higher level math. All right, that's what I've got for you guys today. Take some time to do your practice questions, and then reach out if you need help. All right, thanks a lot, guys. Have a great day. See you soon.